Okay, let's talk about merge sort. So merge sort is a divide and conquer algorithm, which just is a general class of algorithms where you divide the problem into increasingly smaller sizes. In the case of merge sort, we break the array in half, and we continue to break it in half all the way down. That's where the name divide and conquer comes from. We're just sort of breaking this guy into two subarrays. Okay, so 5, 4, 1, 7. And the right-hand side is 2, 6, 8, 3. That's the divide part. So we've taken a big problem, in this case an 8-element array, and we've broken it into two smaller problems, a 4-element array and another 4-element array. And that's where this divide and conquer idea comes from. But so you break it into two smaller pieces, and then you sort those small pieces. And how would you sort this small piece? Well, let's just continue with divide and conquer, right? So you break it in half again, and break it in half again, and again, like that, and you just keep on going till there ain't nowhere to go. So this was the divide part. Then we need to reassemble this stuff back together. So we need to do a merge. So what we're going to do is we're going to compare these two items, sort of run through these arrays and build another array by putting the smaller item first. So we're comparing the 4 and the 5. 4 is smaller, so we put that there. And then we move this down here, and it's done, so we put the 5 in there. So that guy's done. And we would do that. It's kind of trivial for the cases of 1, but you put them back together in sorted order. So the 3 and the 8, right? The 3 goes first. Okay. Then so this was a merge, okay? There was a merge. There was like divides all the way down and then merges back together. So now we're going to merge the next layer up, right? So what we're doing for these merges is we're running through these guys. We're comparing the 4 and the 1. 1 is smaller, so we copy it down here and increment down to the next position. Now we're comparing the 7 and the 4, right? The 7 and the 4. The 4 is smaller, so we copy it down and increment this. So now we're comparing the 5 and the 7. The 5 is smaller, so we copy that down and then move over here. Okay, and then we're done here, so we just copy the remaining elements in this array down here. Right? I'll do that again over on this guy. So you scan through here. You're scanning each one of these. Maybe with 2 pencils would be good. You're looking at the 2 and the 3. The 2 is smaller, so you copy it down here and then move this array down. Now we're comparing the 3 and the 6. The 3 is smaller, so we copy the 3 down and move and increment this index down. So we're comparing the 6 and the 8 now. The 6 is smaller, so we copy the 6 and move this pointer down. And then once we've run off the array, then we just copy the remaining elements down. So 8 is the only guy. Okay? So then we just continue with these merges all the way back out. Right? So we're going to scan, and I'll use my double pointer, my double pencil thingy. So we're comparing a 1 and a 2. 1 is smaller. Copy it, increment this this left array. We're comparing 2 and 4. 2 is smaller. Copy, increment this right array. We're comparing 3 and 4. 3 is smaller. Copy, increment. 4 and 6. 4 is smaller. Copy the 4, increment the left index. 5 and 6. 5 is smaller. Copy the 5, increment the left pointer. 6 and 7. 6 is smaller. Copy the 6. Increment this pointer. 7 and 8. 7 is smaller. Copy. Increment. Then we've run off the end of this list, so we just copy any remaining items down there. Sorted. So that's how you do that. This is a good way to represent this. Maybe let's look at the code. So you call merge sort on indexes 0 through 8, right? These have indexes 7. 0 through, why does it go to 8? It seems like it should go to 7. Oh, I have 9 elements in here and I only have 8 in my example. Anyway, first index to last index. So you come in here, you just divide it in half, right? This first, you pass 0 and 8 in here, you calculate 4. You calculate the middle position. So we're going to break this into 2 arrays, 0, 1, 2, and 3 indexes, and then indexes 4, 5, 6, and 7. So then we call merge sort on 0 to 3, right? First to middle. And then we call merge sort on 4 to 7. You know, we call merge sort for this first subarray, right? Then we call merge sort for the second subarray. And then we sort of abstract all of this. The merge is happening here, right? The merge is happening at this first call into merge sort. The merge, you break this first guy in half here. You call merge sort on this, and you call merge sort on that. This merge sort and this merge sort, they go off and sort these arrays. Right, so when you come back to this instance of merge sort, remember this is recursive. So when you come back to this instance of merge sort, these 2 subarrays are sorted. You see, this all happens in the lower recurses. Yeah. So now we've got a sorted subarray and a sorted subarray to merge. So this merge here is this merge here at this level. But, it's recursive. So, you call this merge sort for this subarray. It comes back into merge sort, another instance of merge sort, which breaks it into 2 smaller arrays, right? This would get abstracted out by the recursive calls, and then you would do a merge on these 2 subarrays that are sorted now. Okay, you have to think recursively. It's a little bit tricky. So, another way to think about that is to draw the recursive trees. So you could do that with this, and that's what I'd like you to do with the homework is a bigger recursive tree. But let me do a small one because it's kind of messy to be thinking about these things. But let's do a recursive hand execution with data on a little bitty array and look at this code here a little bit. So I've got these guys. Let's say I had 10, 30, 40, and 20. And these are the indexes 0, 1, 2, 3. So you call, in main, right? You're going to call msort on elements 0 through 3. Right? We're going to call merge sort on, in this case, 0 through 3. So this is our first call. This is a call to msort, so I'll just indicate it with M. I'll label it out msort. So we're passing a 0 and a 3 into this guy. So the first is 0 and the last is 3. The last is 3, 0 to 3. We calculate the middle, which is going to be this formula here. It's going to be first plus last divided by integer division 2. So 3 divided by integer division 2 is 1. So we're going to call, so we calculate this middle position and then we call msort, right? And we pass it the first and the middle. So we're passing 0 and 1 to another instance of msort, right? We're passing the first and the the last is 1. Okay, then this is going to calculate a new middle, which is going to be 0. And it's going to call merge sort from 0 to 0. It's going to call another instance of merge sort. First will be 0. The last will be 0. This condition will be false, so it'll just return, right? It'll just come on back. And so it did merge sort, right? Came down to here. Now it's coming. Now it calls another merge sort, right? Merge sort. Calls another merge sort from first to last. Is that a 1 or an L? It's got to be an m plus 1. So it's going to go from it's an L. So it's going to call 1 to 1. So the first is 1. The last is 1. This if is false, so it just returns immediately. So it comes back, does a merge, right? So it comes over here, does a merge from first, middle, last. It's passing first, middle, last, right? You could keep track of all these. First, middle, last. You know, it's going to do a merge and come on back. And this guy's gonna. So then it'll come back to here. This was the first call. There was m sort down to here. Now we're coming back, and it's going to do another m sort out to here, and that's going to break. It's going to be similar to this thing here. I ran out of room, but it's going to come. It's going to do an m sort. There's going to be an m sort, and then a merge. Right, so there's this 3-element tree, and then another 3-element tree, and then this guy's going to, and then it's going to return from this all this stuff, and then do another merge. So there's a merge here. There's a merge here and a merge here. It's a tree. If I drew it out a little bit more better, it would look kind of like these guys that are returning real quick. So there's main. There's m sort, which calls m sort twice. Which calls m sort twice, which return right away, and these come back and call merge. And then this comes back and calls m sort, which calls m sort twice. Come back, and then they call a merge. This thing comes back, and then it calls a merge. So it looks like if I drew it a little bit more, if I took the time to draw it out a little bit better. But there's a merge. Okay, what does it look like data-wise? It's kind of why I wanted to identify these merges, because there's going to be 3 merges happening here. So there's this first call to m sort, which breaks this into two pieces. So it breaks it into this thing and this thing. Index is 0 and 1, and index is 2 and 3. So this has the 10 and the 30 in it, and this has the 40 and the 20 in it. Okay, that was the first call to m sort that broke it into 2 pieces. This guy's trying to m sort this first this subarray here, and this guy's trying to sort this subarray here. So it does it by calling m sort, which breaks this into this thing and this thing, 10 and 30, and then it comes back and does the merge. So these get merged into, sorted back together, and then it calls this side, which breaks this thing into the 40 and the 20, and then it comes back and does a merge, and these guys get merged into 20 and 40. Okay, then it comes back to this guy, which calls this merge, and this merge does the final thing, 10, increment, 20, 30, 20, increment, 20, 40, 30, increment, 40. Okay, so I'm trying to go fast enough to get the concept. Apologize for the resulting messiness here, but I would like you to take the time and draw something like this, but much prettier, please. Draw the, use the data that I gave you and draw this array and show it getting split out. So this is like the data view here, right? Which is good. And then draw the recursive tree view. Yeah, and I feel a little bit guilty, you know. Do as I say, not as I do. You know, I mean, I'm trying to explain these and talk about them, and it's hard to do that and make it neat. But you guys, as students, what I want you to do is study this, and the best way to study these, to get this stuff to stick in your brain, is to take the time to draw these guys out neatly, because that forces you to think about what the algorithm's doing. So there's a document that's similar to this, but a little bit neater posted you can look at, if that's helpful to you. And then there's this code thing that you can look at. All right? Thank you.